Hey everyone. So a while back I got this question. Can you please do a video on NBTs? So I was like, yeah, okay. And then doing some advanced research, I was able to get every single piece of information necessary to tackle this task. And through hours and hours of research and preparation, I came across a few questions, and that's what we're going to be doing now. Okay, so the idea behind NBTs is that it's an assessment to help you get into university, and it's just this benchmark test that everyone takes so everyone can be treated at the same level. And well, you could be sitting there thinking, well, everyone writes the same final exam, right? So shouldn't they just use that mark as a benchmark, because it's the same paper that everyone writes in the country, right? And you're not wrong. It's just that when you apply for university, the marks that you will be using is the marks you got on high school, and not all the papers that are written on high school are the same, and they differ on difficulty or the type of school, or so this benchmark test is used by universities just to tell exactly what you know. I don't know. So I was able to find a few questions, and I'm not going to do all of them because I don't want to make this video too long. I know the matrix are starting, I think, soon, depending when this video is going to be out. But yeah, let's go into it. Okay, so all questions will be multiple choice, and you just have to pick your answer, based off of questions, I guess. So we are given the function f defined by y equals to minus x squared plus 6x minus 5. Okay, so, and then they give you type of details, and you should guess which one is right. So let's see what we're working with. So we have minus x squared, right? So that means our parabola will be shaped like that. Okay, what else can we tell? We can see that our y-intercept is going to be minus 5. So if we have a Cartesian plane, negative 5 would be what here, and that means that our graph will cut here. What else can we determine? We can determine that maybe a turning point, minus b over 2a. So I just want to give it the right shape. So it will be 6 over 2, which is minus 3. So minus 3 is about there. Okay, so our graph will look something like that, going through there. Okay, yeah, that's about how our graph's looking. Okay, so now let's see the characteristics they give us. So they say a minimum y value and a negative y-intercept. Okay, so this part is true. It is a negative y-intercept, but this part isn't true. A minimum y value. There's no minimum y value because this graph continues forever down, and you don't get a minimum value. So the next one, p, a maximum y value, which is true. We do obtain here because there's no greater y value than this, and then a positive y-intercept, which we determined before this to be this here. It is a negative, so it can't be positive, right? So therefore that's wrong. That's wrong. A minimum y value, okay, we determined that to be wrong already. So, and then the last one should be right. A maximum y value, yes, and a negative y-intercept, therefore that is true. Right? Easy. Well, can be tricky if you don't know anything about parabolas or graphs. Okay, I think I'm gonna skip this one, but I'll leave it up for you if you wanna have a look at it. Okay, that should be enough time for you to pause. Okay, so next question. They say that question 4 is an example of category transformation and related concepts. So we are dealing with the same parabola, and they say that it is reflected in the x-axis, and the resulting graph is then reflected in the y-axis the new equation is, okay, so what do we do when something is reflected over the x-axis? It's simple. We just change the y value, make the y value negative. Our parabola would become negative y equals to minus x squared plus 6x minus 5. But then we make our y positive because we always want our y to be positive. So this becomes x squared plus 6 minus 6x plus 5. Right? Multiply each side by minus 1. So this is our graph when it's reflected over the x-axis, which kind of makes sense because if we draw this one, because remember our previous our original parabola looks something like that, right? So this graph over here, once it's reflected, you see that the shape of our parabola is now smiling. Our axis cuts through plus 5 now, which is about here, and then it's going to go something like that. Oh, amazing drawing. Like that. Okay. And they say that the resulting graph, which is this one, is then reflected in the y-axis, so over there. Okay, so what we do for that, we're going to make our x values all negative. Right? So it would be y equals to negative x squared minus 6 negative x plus 5, which equals to, this stays the same, this becomes plus 6x plus 5. Right? So if we draw this graph, notice how the intercept stays the same, but our turning point becomes over here. So the graph becomes something like this. Oh, and look, that is one of our answers. Okay, next one. So they say, for any real number x, which one of the following statements is always true? So we have minus x is less than 0, 1 over x is rational, x divided by x plus 1 is less than 1, or 1 over x is always greater than x if x is between 0 and 1. Okay, so let's go through them one by one. So the first one, this is, what would you say? That says false, because any real number, so that means negative numbers are real numbers as well. So if you add something like minus 2, and let's substitute minus 2 in, it's less than 0, this becomes positive 2. So you're left with positive 2 is less than 0, which obviously isn't true. So therefore this one's wrong. Okay, next one. So we have 1 over x is rational. So this works for most cases. The only one it doesn't work for is when x equals 0, because 1 over 0 is undefined. Yes, good job. So therefore this statement is not rational, therefore this is wrong. Okay, so next one, we have x divided by x plus 1 is less than 1. So this is always true, besides for one case. So similar to this one, can you guess what it is? Yeah, it's when the denominator is going to be 0. That's like always the case. So notice when this here is going to be equal to 0, right? So that means x plus 1 equals to 0, so therefore x equals to minus 1. So this case here, when x equals to minus 1, you're going to be left with minus 1 over 0. And it's this exact same thing again. So therefore, that would be undefined, and therefore this is wrong. So this works for every other case besides this one case. Okay, for this last one, we have 1 over x is greater than 1. So this is always true, because no matter what number you substitute in from 0, actually you can't put in 0, but like between 0 and 1, this will always be greater than 1, which is true. Okay, and test that on your calculator. In any number, any fraction, you have 0.1, 2, 3, 4, whatever. Put that under 1, and then this answer you get will be greater than 1. Alright, okay, so the next one says the next two questions are in trigonometric category. Yeah, so trig, everyone's favorite. So question 6 depends on your understanding of compound angles, and question 7 revolves around ratios in two-dimensional situations. I don't think I'm gonna do that one, depending on time. Okay, so we have sine 43 degrees, cos 23 degrees, minus cos 43 sine 23. Okay, so it looks all complicated, but it's not. Right? This over here is actually an identity. So if you notice, we have sine let's call this theta, cos sine theta, cos I know what's another letter, beta, minus cos sine beta. Okay, so this here is equal to, this is same thing as double angles, but this would give us sine alpha, same sine minus beta. Okay, so sine is same sine, right? So coming back to our example, we're just gonna have sine 43 minus 23, which gives us sine of, don't know why I sounded so excited for it, which is 20. And there we go. How's your uncle? I guess what, this would be pretty hard to do if you didn't remember this. Okay, let's move on. Okay, so that's a nice one. So let's do this one. So say question 8 combines your understanding of algebraic manipulation and spherical awareness, whatever. Question 9 is your understanding of 2 or 3 dimensional objects, as well as surface area. Okay, so forget my poor reading. Let's go into number 8. So suppose ABCD is a square with a length of x minus 1. So ABCD, so this is x minus 1 over here on all sides, and they say if the area of the rectangle ABFE is this over here, then the length of CFC, which is this length over here, is equal in centimeters is, okay, cool. So the trick to this is, how do you determine the area of a rectangle? So it's just going to be your length times your breadth, right? So it would be your length times your breadth is equal to what was given, which is just going to be our x squared plus x minus 2. So this over here we can factorize, so that if we factorize it will give us x plus 2 minus 1. Okay, so that's what happened when we factorize. And our length times our breadth, we don't know what our length is. I think this is the length and this is breadth, but notice this is a square, so this side here is also x minus 1, right? So we're gonna have our length times x minus 1, and then you notice x minus 1 is on both sides, so therefore our length is equal to x plus 2. Okay, so they're asking us to give CF, so our length is this whole thing over here. So how do we get that part? We simply minus our side, which guess what is still x plus 1. So we're gonna have x plus 2 minus x minus 1. Therefore the x's cancel, we are left with 2 plus 1, which equals to 3. centimeters. Right? Easy work. Just a lot of manipulation. Wow. Greatest joke ever written. To be made up on the spot. Okay, question number 9. So we have that. This is actually really nice. I like this as well. Oh, wait. I'm enjoying this a little too much. Okay, so the figure represents an empty cube with a circular opening at the top. The diameter of the opening is half the length of the diagonal AP. Very complicated if you don't know what any of those means. The outer surface area of the cube is one of those. Okay, so how do we determine surface area of a cube? It is the number of sides times length times breadth, right? But since it's a cube, it's the same thing. That's why we have 6 multiplied by a squared, because it's a side, because the side is a centimeters, so it's a squared times 1, 2, 3, 4, 5, 6 sides. Okay, but you notice that where this negative over here is just the circle that's being cut out of our surface area. Okay, so how are we going to determine this surface area of our circle? So they tell us that the diameter is half the length of the diagonal AB. Okay, so let's just redraw this perfectly, obviously. Okay, so this is B, that's just a top view, eh? So we have a circle in here, and they say that the diameter, which is this distance over here, is, let's call that diameter, so that distance over here, is equal to half the diagonal, which is this distance, right? That distance, AP. Okay, so how do we determine AB? So remember, it's a cube, so this length here is A, this length here is A, it's a cube, therefore this is 90 degrees. We can use Pythagoras, and then therefore AB, just write out, is equal to A squared plus A squared, squared as well. So you can solve this. AB then equals to square root 2 of A. Right? So this becomes therefore the diameter is equal to square root 2 of A over 2. Right? Okay, so how do we determine the surface area? Surface area of a circle is equal to surface area circle equals to 2 power. Yeah, I had to think there for a moment. 2 power circle times its radius. But remember, we have diameter, not radius, and radius. Let me just make a line. Radius equals to half diameter. So therefore radius is going to be equal to root 2 A over 4. Oh wait. No, what am I doing? No, this is like that surface area, not the perimeter. Perimeter is that. This is because it's a whole square. Okay, yeah. Mistakes found. We didn't do anything wrong. Okay, so now we have to substitute this R value into here. So then our surface area becomes pi, this whole thing squared, so it's going to become 2A squared over 16, 4 squared, right? Okay, and then 2 over 8, jumping the gun here, 2 over 16 gives us 1 over 8, so we have pi A squared over 8, which is this one. Yeah. You understand? Oh, I kind of rushed that, but that's fine. That's fine. That's fine. NBTs, eh? NBTs. Okay, the last one is a financial question. Nice. So it is calculating interest. I'm not going to do this. I'm pretty sure I ran out of time. Probably not going to add this in the video. If I do, yeah, whatever. So you're just going to substitute all your values in and then pick one. If you really struggle with it, I'll just drop a comment or whatever. And yeah, see you in the next one, guys. Cheers.